Okay, this is more on the Ainslie Figure 3 scope trace. What you're looking at there is the function generator output, and then this is the trace through the current viewing resistor. This is the gold and yellow trace on Ainslie scopes. This is the blue trace. So what I'm going to do is just to, and I'm only running with 4 batteries here. This is the temperature of the Q1 MOSFET. That's a little bit warm now. Ambient here is about 20 degrees right now. And this is the DC current from the 4 batteries through the system. Now what I'm going to show here, what I showed before was that the Ainslie Figure 3 scope trace can be produced by pulling the MOSFET. But that's a little too obvious. I've discovered that there's another easier way to do it that actually actually cracks me up, man. Okay, so anyway, this, if I turn up the function generator amplitude right here, this, by the way, this is at 5 volts per division on the gate drive signal, and this is at 2 volts per division on the current viewing resistor trace. Very similar, the same settings that Ainslie shows. So anyhow, I'll pull up the amplitude on the function generator until it peaks. There, I can't get any more positive amplitude out of it because of the clipping effect that's determined by the total voltage of the battery and the voltage drop through the body diodes of the MOSFET's concerned. So here we're clipping at about 7 or about 8 volts, and it just won't go any higher than that no matter how much I crank up the generator. But notice that there's plenty of current well above baseline on those Q1 on periods there. Plenty of current indicated, and if I turn the amplitude back down so that I can take a good reading, we see that the MOSFET has warmed up a bit from that, 33 now, 33, 34, and the load actually started this at 80 and now it's up to 96 degrees Fahrenheit there on the oil on the load. And what I want to illustrate here is a little bit something else. I'm going to make just one small error, and then I'm going to turn up the amplitude again. And I think you can see that I still have plenty of nice oscillations in the current viewing trace, but there's no current indicated in the between times. We're still topping out at around 7 volts or 8 volts on the clipping of the gate trace, but I think you can see that the current viewing trace has oscillations, but there's no current shown in there. Yet the MOSFET is still in place. It's still warming up perceptibly, and it's still heating the load. We're up to slightly over, just slightly over 100 degrees Fahrenheit now. Okay, so we're showing this trace. We have oscillations and no indicated current flow. That's up a little bit because of the baseline drift. Let me get that exactly back on the baseline. So we'll go back to the display. So there, my function generator is actually turned up to its maximum amplitude right now. Okay, and yet we're still topping off at about 7 or 8 volts. It's about 8.5 volts, I guess, on the gate drive trace, because I've only got 4 batteries in there. If I had 6 batteries in there, this would be going up to about 12 volts. The gate drive trace would be, with full power on the function generator. But as you can see, there's no current indicated in between those nice oscillations there. And yet, that MOSFET is warming up nicely. And we've got the load obviously warming. That's the temperature of the oil, remember. And let me turn down the oscillation so we can get a good reading on the flute thermometer. Okay, and the MOSFET's heating up. Okay, what's going on here? Why am I not seeing any current flow even though everything is hooked up? And I still am seeing oscillations. Well, the answer to this particular puzzle is that I have the current monitoring probe on the wrong side of the current viewing resistor. If it was just moved from here to here, it'll indicate the current correctly. But all I did was move the probe tip from here to here, the other side of that current viewing resistor. And that gives me the Ainslie figure 3 scope trace. But I discovered something even more interesting. Watch this. I'll just take that probe off. And look at the resulting scope trace. I still get plenty of oscillations, but the probe is picking up RF from the circuit, and the position of it really makes a difference in that particular set of oscillations there. I can maneuver this disconnected probe around until I see something, again, very similar to some of the traces Ainslie has shown, with zero current indicated in the Q1 on times, because the probe is simply disconnected. Then I get back to the trace that shows plenty of current in between when the Q1s are on. Okay, and we turn down the oscillations. The Q1 MOSFET is now up to 47 degrees. And the load has risen to 119 degrees Fahrenheit. And we've done that with mostly a figure 3 scope trace. And I'm going to omit the stage where I take the MOSFET out and show that it is intact, because it's obviously intact. The only thing that's wrong is that the one simple error in hooking up the oscilloscope probe has caused an Ainslie figure 3 scope trace. Thank you for watching.